If you want the step-by-step output of Gauss Jordan elimination method to solve the system of equations, then watch this video till end. Hi, this video is also for all those students who are using the MATLAB for the first time. So if you don't have any MATLAB software, then you can easily download it from the above link, in which step-by-step installation procedure has been shown through a tutorial. So in order to find step-by-step output of Gauss Jordan method, we must have its MATLAB file, which can easily be downloaded from the link given in the video description. Click on the link and download the Gauss Jordan M file. It will appear in your downloads folder. Now we have to place this M file in the MATLAB current folder window. For this, open the MATLAB software, copy the MATLAB folder address from this bar and paste it into some other folder address bar. Now copy the Gauss Jordan M file from downloads and paste it into the MATLAB folder. If you are using MATLAB for the first time, then this folder will be empty. But as I have used this folder many times, so I have so many files here, so don't worry about that. Now go to the MATLAB. You will see the Gauss Jordan M file here, this one. The hard part is over. You just have to write the file name GAUSS_Jordan JORDAN. Press enter. This is it. Solving the system of equations using Gauss Jordan method. In this method, we convert the augmented matrix into reduced echelon form. Enter the augmented matrix. For example, we have this system of equations which we have to solve by using Gauss Jordan elimination method. So we have to convert this system into the augmented matrix like this. Now we have to write this into the MATLAB. To write a matrix in MATLAB, we first have to put square bracket, then enter the first row elements, which is 2 space -2, again space 2, and then 1. Now we have to shift to the second row, press enter, and enter the second row values, which are -3 space 6 space 0 space -1. Now the third row values 1 -7 10 and 2. Now in order to close the matrix, we have to put the square bracket again. Now press enter, and that's it. We got the solution in nanoseconds. So what it says, as you know that Gauss Jordan method has two phases. The one is the forward phase and the second is the reverse phase, which is also called a back substitution. So first of all, what it did, that it swapped the row 3 with R1 because we have 1 in the third row. Okay, fine. So this is your new augmented matrix. Now R2 -3 R1 because we have to make zeros below the pivot element in the first column, so we have eliminated -3. In the second step, we have eliminated the 2. Now we have -15 as our pivot element. In the second column, we have to convert it into again 1. So divided in the whole row with -15. So this is a step-by-step procedure which MATLAB is showing you. So you don't have to calculate manually and just put the answers in the notebook. So next, R3 -R2, we have make 0 in the below the pivot element in the second column. And again, now we have 6 as a pivot element in the third row. We have to again reduce it into 1. So dividing the whole row with 6. Now the reverse phase or back substitution phase has started. So what we have to do in the reverse phase is that we have to convert all the elements above the pivot into 0. So we have subtracted the -2 times third row from the second row and converted it into 0. And the next procedure will be done for the first element in the third column. Now there is only one element remaining. In the second column, we have converted it into 0. So our main aim is to convert the augmented matrix into reduced echelon form. So if you have an identity matrix, then you got the single solution. But other cases are also possible, which are no solution case and the multiple solution case. So let's try out for those. So to try another example, we again write the file name, which is Gauss GAUSS_Jordan. You have to pay attention to the spellings. Press enter, and we have again the same interface. Now let's take another example. For example, this one. First convert it into the augmented matrix. write the augmented matrix. So as we know that to write the matrix we have to put the square bracket and the first row values, which are 1 space 2 space minus 3 and 0. For the next row values we have to put enter. Now second row values 2 4 minus 2 and 2. Again for third row we have to press enter. 3 6 minus 4 and 3, bracket close, press enter. Now we have a forward phase, but in the forward phase we have the third row in which all the elements are 0 except the last one. So as we know, this is the condition for no solution. So our system has given no solution. Now let's try out for the infinite solutions. What will be the case then? Again write the file name Gauss underscore Jordan. We again take another system of equations. Now convert the system of equation into augmented matrix and write the augmented matrix. We know the drill. 2 5 9 minus 2 8, enter. 1 minus 2 3 1 2, enter. 1 1 4 minus 1 and 3, bracket close, press enter. So this is your step-by-step solution of Gauss Jordan method. Swapping R2 with R1, the same procedure. Let's see the result. So I hope you find this tutorial useful. So kindly like it and comment on this video and also share it with others. So if you have any confusion in this video, feel free to ask in the comment section. Thank you very much.